Hi everyone. So in this video, we're going to work through a Year 12 Pure Maths question from the AS 2018 paper. And this question is on trig identities and trig equations. So for part A, show that the equation 4 cos theta minus 1 equals 2 sine theta tan theta can be written in the form 6 cos squared theta minus cos theta minus 2 is equal to 0. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level maths topics that will come up in your 2027 exams. So now that the 2026 exams have finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018 and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up. Sign up to the app and you'll be able to access all of these 2027 predictions. Now, for this part A, we're trying to convert this equation into an equation with coses. So obviously that equation we need to achieve just has the cos function in the equation. There's no sine, there's no tan. So we're going to have to convert these sines and tans in the original equation to get the formula or the equation that we're looking for. So let's just start by writing down 4 cos theta minus 1 is equal to 2 sine theta. And then let's use one of our identities involving tan. So hopefully you remember that tan theta is the same as sine theta over cos theta. So let's use that formula. So we've got here sine theta over cos theta. So then this gives us 4 cos theta minus 1 is equal to 2. And then sine theta times sine theta gives you a sine squared theta, and then divide by cos theta there. Now we can multiply over the cos theta to the left side. So this then gives us 4 cos squared theta minus cos theta is equal to 2 sine squared. Now, if you remember one of the other trig identities, you will hopefully remember that sine squared plus cos squared is equal to 1. Let's just write this down here. So sine squared theta plus cos squared theta is 1. So therefore, this means that sine squared theta is equal to 1 minus cos squared theta. So we can now sub this into the right-hand side. So we have 2 multiplied by 1 minus cos squared theta. So this, of course, gives us 2, and then minus 2 cos squared theta. And then we can now move the 2 terms on the right side over to the left side. So we now have 4 cos squared theta plus 2 cos squared theta, because we're moving that 2 cos squared theta to the left side, and then minus cos theta, and then minus 2 equals 0. So therefore we get exactly as we needed, 6 cos squared theta minus cos theta minus 2 is equal to 0. And that is our part A answer there. Just another quick interjection. If you are currently doing Edexcel A-level maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. Great, so now let's move on to part B. So for part B, hence solve for x between 0 and 90 for cos 3x minus 1 is equal to 2 sine 3x times by tan 3x, giving your answers where appropriate to one decimal place. Okay, now hopefully you can see that the structure of that equation is the same as the original equation in part A. But can you spot the difference? The difference is that the theta from part A has become a 3x. That's the only difference. Same structure, same functions. It's just the argument of the function has changed to a 3x instead. So basically, as we know from part A, this equation here is equivalent to this equation. So basically, we can just say using part A, it must be true that 6 cos squared 3x minus cos 3x minus 2 is equal to 0. So let's just make a note of that down here. So from part A, it is clear that the equation in this question leads us to 6 cos squared, and then again change it to a 3x this time. So 3x minus cos 3x minus 2 equal to 0. Perfect. Now then, this is kind of like a quadratic in disguise. So what you could do if you want to, you could let y be equal to cos 3x. So then this creates a quadratic in the variable y. So 6y squared minus y minus 2 is equal to 0. Now we can attempt to factorize this quadratic here. So if we try to factorize this quadratic, what you can do is you can take the y squared coefficient, times it by the constant minus 2. This gives you minus 12. So we're looking for factors of minus 12 that add up to make minus 1. Hopefully you would be able to realize that you could use minus 4 and 3 to do this. So what we're going to do is write down 6y squared minus 4y plus 3y minus 2 equals 0. And then now we can factorize this here. So what we can do now is look at the first two terms, factorize out a 2y from the first two terms, so 2y, and then this leaves us with 3y minus 2 there. And then we have here a 3y minus 2 as well equal to 0. So we can factorize out the 3y minus 2, and this leaves us with 3y minus 2 multiplied by 2y plus 1, and that is our factorization there. So I've used quite a long-winded method there to factorize this, just because if we go back to here, in the question, it says solutions based entirely on graphical or numerical methods are not successful. So I just want to show the examiner sufficient working here with this question. So we factorise that. So therefore, it's clear that y is equal to 2 over 3 or y is equal to minus 1 over 2. Now, we know from before that obviously y is cos 3x. So now we can sub in cos 3x. Cos 3x here is 2 over 3 or cos 3x is equal to minus 1 over 2. Perfect. Now, I'm just going to go back and underline the range of x values we have to solve for. So our solutions have to be between 0 inclusive and 90 not inclusive. So what we have to realize is that if x is between 0 and 90, then that therefore means that 3x, the angle we have in this problem, must be between 0, and 270. So multiplying the range by 3. So we're going to take a cos inverse. Let's call that equation 1. Let's call that equation 2. So from equation 1, we have cos inverse of 2 over 3. And on my calculator, cos inverse of 2 over 3 gives me 48.1896. I'm going to just round that to 3 decimal places. So that would be 48.1903 dp. And then from equation 2, I'm going to take cos inverse of minus a half. Cos inverse minus a half. And on my calculator, this gives me 120. So 120 degrees for that one. Now, both of those angles are between 0 and 270, so they're both okay. But there could be other solutions. So this is where we just need to draw a cos wave and just work out if there will be more solutions. So obviously that's 0 degrees on the x-axis. That's 90 degrees there. That's 180 degrees there. And that's 270. Now we need to stop at 270. We're not allowed to go beyond 270 because the angle 3x has to be between 0 and 270. So what we can now do is label these y values. So we've got 2/3 that y value. So let's put 2/3 there. The calculator's given us this value, so this 48 value there, 48.19. And if we continue, we will see there will be no other solutions for cos 3x equal to minus a half, because we now go out of bounds beyond the 270 for the next solution. Now we have, of course, this other y value of minus 1 over 2. Just put minus 1 over 2 down there. So again, the calculator's given us this angle there, which we know is 120. But we can see there is going to be another angle here, this angle there. Now that angle is going to be 360, take away 120, because remember, between 0 degrees and 360, obviously 360 is over there, you have a line of symmetry at 180 degrees in the middle of this cos wave. So you can do 360 take away 180, sorry, 360 take away 120 to give you the second angle here. So that's going to be 240 degrees. Perfect. So we've got 3 possibilities, this one, and this one. So therefore 3x is equal to 48.19 or 120 or 240. And now the last step is just divide by 3. Okay, so 48.19 divided by 3 to 1 decimal place. I think the question wanted 1 dp. It did, yeah, 1 decimal place. This will give you 16.1. So 16.1 degrees. Divide 120 by 3 is 40 degrees. Divide 240 by 3, that would be 80 degrees. And those are our 3 solutions there to 1 dp where required. I mean, the 40 and the 80, you can just leave that as integers, that's fine. But the 16.1, we've rounded that to 1 decimal place. Perfect. Now, hopefully all of that does make sense. But if you do have any questions on the process I followed there, do feel free to drop a comment below.